Oh well, let's see how long you last. All right. Deep cleansing breath. There you go. Somebody took me up on the advice. It's amazing how it helps. It's like chocolate versus Dementors. Green. So I talked a little bit about one of these topics already. But I want to tell you about this number E we talked about briefly before, right? So there is a very, very special, in fact, let me start off with something, I can't remember exactly how much I've talked about this, but you guys know pi, right? Where did it come from?
Reality.
Yes. Can you be, like, just a little more specific? You're like, no, I thought you'd like that answer, Jeff. Yes?
Circle.
True, came from a circle. That's why it's always involved with circles, because it actually comes from circles. To be honest, one of the formulas you guys probably know, you must know this formula, comes from where we discovered pi in the first place. If you take any circle, I don't care how big, how small, right? And you take its diameter and you take its circumference, if you divide those two, you always get the same number, no matter the size of the circle. I think I talked about this a little bit. It freaked people out. Are you guys with me? Now, on one level, I hope to God this kind of makes sense. Because as a circle grows, the circumference and diameter grows by the same proportion. So, of course, the division of them will come out to be the same number. So, that fact is only a little bit freaky. It's just, why is it the number it is? That's what's freaky. I mean, it had to be something. So when you take, in fact, you can do this with a piece of string. You can measure the piece of string. That'll be the circumference, because the next thing I'll do with it is form it into a circle, measure the diameter. And anytime you do that, I don't care how long the string is, it could be from here to Jupiter, or it could be this big. You make a little circle. When you divide the two, you always get the same number. You get 3.14159, blah, 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 blah. So real quick, March 14th, 2015 was what us math people called Superpi Days. I was at a conference and they had pi after pi, blah, blah, blah. I was like, all right, guys, even I'm getting a little sick of this. That's all beside the point. But you understand the idea? Any circumference divided by diameter of any size circle will always come out to be this number. The Egyptians had a rough estimate of it. The Greeks had a rough estimate of it. Every civilization, basically. Nowadays, we can do computers out to millions and millions of places. So we just gave this the letter pi. We called it pi because it's an interesting number. Wouldn't you agree that's an interesting number? If you're some mathematician, some ancient civilization, you're looking at a circle, you just happen to notice this. Wouldn't this freak you out a little bit? Wouldn't you think maybe this is given to you by the gods or something, right? There's another number called the golden ratio. Some of you guys know it. It comes from a certain sequence called the Fibonacci Sequence. I love it. And that one certainly they thought it came from the gods. And some of the pyramids are built according to it, and some people are not aware. They're not sure if they knew it, or if it's because that number actually defines the most aesthetically pleasing things. It actually kind of describes a way to set things up. So it might have just happened. Anyway, pi freaked us out, so we gave it a symbol. Yes?
How about the vortexes?
Vortices?
Vortexes, I don't know. Like, it's like with 9, and everything always goes back to 9 and stuff. No.
Well, of course, 9 is, 18, 27. You add them up, it becomes 9. So it's got a lot of other little properties, too, because of that. So it's probably, I'll bet you anything, if you look at it, it boils down to that. But you have to show me later.
Yeah.
I'm not really sure what you're talking about. All right. So that's pi. That's more than you ever realized about pi, more than you wanted to know about pi. But too damn bad. Now, there are some really boring-ass places where this next number comes from, but there's one really, really cool place, and there's one medium cool place that this thing comes from. Just stay with me, all right? Everything I'm about to say is just explaining a little bit about why we gave this thing a letter, because I feel like you should know that, instead of just, here's a letter. To me, the most interesting place where this thing comes from is, if you take the graph, if you take the y equals 1 over x function. Real quick, we never graphed this thing, but does this graph make sense? Like, what's 1 over 1? 1 over 1 is 1, right? What's 1 over 2? 1/2. Is everybody with me so far? What's 1 divided by 1/2? 1 divided by 1/2? 1 divided by 1/2 is 1 times 2 is 2. So you see that shape, that's the shape that the y equals 1 over x line makes, because this is really just the flip function. Whatever the number it is, flip it. Stop there, you guys with me. We talked a little bit about this function because it's its own inverse, for example. That's when we talked about this guy. It is the flip functions. How do you undo that? You flip it again. So it's its own inverse. Okay, all right. You're at least looking this direction. So here's the thing. This is a really interesting question. How far would I have to go from here until the area in there is exactly 1? Now, some of you guys are like, and I don't blame you, but this is kind of interesting. I mean, a little tiny bit. So you end up having to go to this number E, which is 2.7128, blah, 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 whatever. If you go out that far, if you start at 1 and go to E, you get exactly an area of 1 in there, because that's one place where this E comes from. Somebody have a calculator. All right, good. I like it. Beautiful. I hate in math class when I say that and nobody moves. I'm like, nobody, it's math class. So some of you guys have a comment. Don't feel too bad if you don't. Feel a little bad. Let me ask you, let me put an X here just so this looks a little more like what we're used to. Okay. Let's try some stuff out. Do you guys see what's happening here with this expression? 1 plus 1 over x to the x. So a really interesting question about this. This shows up in finance when you're calculating compound interest. If you put something into account and it's continuously compounding, you're making money on it continuously. This is part of how you can figure out how much money you have at the end of so much time, whatever, how much time. Let me give this a little name. Let's call it the f of x function. That's crazy. Let's try to do just some simple things. What about f of 2? That would be 1 plus 1/2 squared, right? And what would that be? We can do this without a calculator, by the way. 2 over 2 plus 1 over 2 is 3 over 2. And when you square that, you get 9 over 4, which is 2 1/4. All right, so 2.25. Already, it's not very far off from here. I hopefully understand that whatever I'm going to do is somehow going to lead to this. It's going to get closer and closer. So let's try to step this up. Let's do one that we definitely need a calculator for. Well, maybe let's do this one. Let's do f of 10. We don't really need a calculator for that. Yeah, we do. Not the inside, though. This will be 11/10 to the 10th power. See, I'll do it with you guys. Oh. Little notes. What do you guys get? 2.5937, blah, blah, blah. See how it got a little bigger? Now let's try f of 100. Let's go. Let's just go crazy. That's crazy, Jim. Let me get what that might be. I get 2.7. Yeah, 0.48, blah, blah, blah. Obviously, I'm trying to connect it to this number I'm talking about, right? I'm not trying to. I'm letting it happen. So if I do f of 1,000, it's going to be basically it. So 1 plus 1 over 1,000 to the 1,000. 2.7169. So if you kept going past 1,000, it would eventually get closer and closer to E. Oh, okay. I see what I did. Down an 8. Show up. All right. Now, I mean, so on one level, a little part of me wants you to realize, sure, I like math. I teach math. I'm still a human. I'm hoping there's a little bit of your human that likes this idea. I mean, this is kind of neat. This, if you happen to notice this, just messing with something, either doing this, which for some reason you would do this. To be honest, most of early mathematics came from either astronomy or gambling, probability theory, right? People trying to win more money and people trying to look up because they were tired of what's going around them. Oh shit, when's that planet come back? Let me calculate that shit. Or let me put some money down on that. How much money should I put down? So a lot of this stuff came from money considerations or astronomy considerations. But still, if you saw that coming out of your work, you would say, holy shit, let me give that a letter. And Euler is the one that kind of ended up giving this guy a letter. I think I told you this. Euler, of course, his name is E-U-L-E-R. He gave this the letter E, not because of his last name, because it was the next in the list of things he was giving letters to. So that's a little aside. So the letter E, just like pi, the letter E in mathematics is 2.71828 blah, blah, blah. The official definition of E is it's the limit. Let me throw this down here and see what you guys think. What were we letting happen to X here? Bless you. What were we letting happen to X? We were letting X get
closer to.
No, we were letting X get bigger and bigger and bigger. We were letting X go to infinity. And I wanted to know, what's the limit? What's the limit of this as we let X get really, really, really big?
The limit does not exist.
Say again?
The limit does not exist.
That does happen, of course, but not here. We know the limit exists. And all right, one last thing about this, and then I'll come back down. All right. As this gets really, really big, what's happening to this? 1 divided by really freaking big is really freaking small. So what's happening to the inside? It's getting closer and closer to 1 because I'm adding something that's getting smaller and smaller. Is everybody with me? The inside is getting closer and closer to 1. What's happening to the power? It's going crazy. I'm letting it get really freaking big. So this is going towards 1 to the big. And 1 to anything should be 1, right? And anything to the big should be big. So you got these two competing things. The inside never quite gets to 1. This never quite gets to, like, there is no biggest number. So they both kind of just agree, they compromise on this number. That's really neat. Why that number? And once we saw this, we started realizing it just naturally pops up in a lot of places. Just like pi does. Pi comes up in the weirdest places. It's involved in the probability that if you drop a needle onto a lined piece of paper, that the needle will cross a line on the paper. The probability that that will happen, pi is in the answer. It has to do with the fact that the needle can rotate. It's really just, these things come out of nowhere at us. And we're like, oh, that's so cool that we figured this shit out before and gave it a letter. All right. I'll bring it back down. Everything I just talked about was just kind of background of these things you're going to be working with. But I'd like to have some idea of where they came from, why we gave it. We don't go around giving letters. I like the number 7.8. I'm going to call it W. No. There's got to be something. Okay, so what you're going to be worried about is, this is the only other, if I've written this down once before, this is the only other time I'm ever going to write this, because it hurts me physically. Log base e of x. Just cross that out right now, but that is this symbol. That is the symbol we use. E, it turns out, describes population growth, for example. It describes decay of radioactive materials. So remember what a to the x looks like? Looks like that. So if you go this way, it describes how materials decay over time, right? Like Chernobyl, radioactivity, horror movies happen, but then over time, the radioactivity decreases, right? Or if you throw a couple rabbits in a room with a lot of food, then over time, you keep opening that door, it's like, oh, there's more in there. It's amazing. Right? Don't think about the implications of there's only two. And what the little babies are doing, it's just nature. It has that. So E is used a lot to describe those kind of processes. So that's part of the reason why we call it the natural log. It is a logarithm that naturally shows up in a lot of these processes that describe natural events. How radioactivity decreases, how rabbit populations increase. If you give enough food and, dim the lights. All right, ready to remain? Yes?
So pi is for like circles and stuff. So what E is for graphing?
E is for growth and decay. It's the quickest way to say that. It's because of the shape of it. But you're like, well, why not 3 to the x? Why has it got to be e to the x? Because e happens to be the number that allows for, if I know something's growing at 1.2%, for example, then the function describing this would be e to the 0.012x. 1.2% is 0.012. It's the base that allows us to use the information we know directly. So it's the most useful base for things that are growing at a certain rate or decaying at a certain rate. Okay. All right. So with that's the first part about this section, the natural log. So when you see ln, you know it means log base e. So let me ask you a couple quick questions. You do not need a calculator for this. What is natural log of e to the 7th? You do not need a calculator for that. You don't even need pencil and paper for that. You can just write it down in your notes. What's log base 2 of 2 to the 7th? 7. Now you could bring it down and all that extra shit, but why would you? There's two ways to look at this. Log base 2 and 2 cancel because they're opposite functions, right? That's how we developed logarithms. They are the inverses of exponentials. What do inverse functions do to each other? They kill each other. I see you, they kill each other. Right? Pop! Or 2 to what power is 2 to the 7th? 7. So, here. That is log base e. That's the symbol for it. So what do these do to each other? Kill each other. So the answer is yes. Of course. No. Just to be evil for a minute, because I'm a math guy. From what I've graded so far, we have trouble with this. But that is the idea. These are inverse functions, just like cube root would kill a cube. Same way. So what is e to the natural log of x? What do the natural log and e to a power do to each other? Cancel. So the answer is x. Yes?
So for the natural log, E, is it the base?
E is the base. Yes, totally.
Okay.
That symbol means the same thing as this. Just please don't write this. Get used to this. It's like writing square root of 9. What, please, somebody tell me that bothers you a little bit. Something, just pretend like it does. Or be honest with you, even better. Doesn't that bother you just a little bit? I know some of you guys do this, and that bothers me. Obviously, it doesn't bother you, but it should bother you. You should be like, no, that's not the symbol for square root. The symbol for square root is that. And then you're like, well, it means 2 there. I know it means that, so we don't write the damn 2, do we? So ln is the symbol for log base e. Why write this shit then? We have a symbol for it. ln. Is that cool by itself? All right, I had people look at me like I was insane for this. Can somebody tell me, what does this, I'm just going to do this once. What does that represent? Can anyone tell me what that represents? The log of no, log base A of W. What does it represent?
A to something.
Beautiful. Because a log is always a power. Log is always a power. That's why the properties of logs are the same as the properties of powers. So this symbol represents the power that A needs to become W. You guys with me? Whatever this number is, if I raise A to it, I'm going to get what? W. This is the power A needs to become W. So what happens when I raise A to it? We just said what would happen, didn't we? Even better, a different way to look at it is that is the power that A needs to become W, so when I raise A to it, I get frickin' W. Because that's what it does, by definition. Yes, good. So the other way to look at it is what I just said. The better way to look at it is these kill each other. So there's 2 different ways to look at that same thing. The same way, what would happen here? What's the cube root of x to the cube? X to the third?
X.
Because what do these do to each other? Kill each other. So this and this are inverse property functions. This and this are inverse functions. This and there and there's and there's. So of course they kill each other like they always would. What is this? Yes, these kill each other. Do you see how, did I tell you what those were? No, I didn't tell you what these are. If a function has its inverse in it, a function has its inverse in it, a function has its inverse in it, they of course will kill each other. That's why we call them inverses. How are we doing? Okay, I like it. I won most of you over. Some of you still look at me like I'm crazy, and I'm used to it because I teach math and I am crazy. Okay. There's one other base. Yes?
So, log with the E, you cancel that out too.
No. What do you mean? Sorry. Oh, this symbol here?
Those are the opposites.
This symbol?
Uh-huh.
So, just like this is log base 2, I got to stick to my promise. I'm never going to write this thing again. I'm just going to point at it. Log base E is the natural log. That's why these killed each other, because that is log base E. You will never write that, though, will you? If you do that with your next teacher, they will come find me and slap me. And I'll kick him somewhere. Because I'll be like, they could do it as what shit I want you. I told them not to do that shit. Okay, maybe. Why do you think the square root doesn't have a 2 in it? Why did we decide to do that? So why didn't we do that with the 7th root? We go, let's just not write the 7. Why the square root? Most commonly used root. So of course we're not going to write the 2, so we save a little bit of time. Over hundreds of years, we saved a lot of time. I'm sorry. So, building into the next little topic in 12.5, one more log base in 12.5 to talk about. That's the common logarithm. What is the most important number in our number system? 10, because that's what our number system is based on. So and this one also, I'm only going to write once. Log base 10 of x. You guys don't believe me, but that does hurt me on some level to write that. That is known as log x. When you don't see a base, It's understood to mean base 10. The same way when you don't see a root number, it's understood to be square root, because they're both the most commonly used ones. Yes?
I thought it was supposed to be like 2 though.
What?
I'm getting confused with something else, but like
Square root.
that would be the square root.
Square root has a 2 there, we just don't write it.
Yeah, but like a while back I saw log base 2 of x, and they said like, oh, that's the one that is most common or something like that.
You got to tell me where you saw that shit, because I got to shut them down. More than likely, you mixed a couple things together.
All right.
But it's not impossible. That is sitting somewhere, and it needs to be burned. Okay. So what is log of 10 to the b? B. All right, sweet. That is how quickly that should happen. Right? And of course, what is 10 to the log of 7? 7. I like it. Now, we are going to use a calculator a couple times today, so if you want to borrow one, you know how that works. Sure. I can always auction a car off. Make sure it works. Make sure it works. Everything. Exactly. And then you got a calculator. That's all it takes. Yeah. Screw Jeff. He gets a check. He can pay for it. All right. Let's try a couple things. Let's do one that's so this is pure calculator stuff. There's a missing letter. There it is. Calculator. There it is. Oh, go ahead. Make sure it works. Can you guys find the LN button? It's on the left side, a couple steps above on. You see it? What's right above the LN button? I mean, yeah. So log base 10 is right above LN. What's right above the LN button? Yeah, that's crazy. What's right above the log button? That's crazy. Oh my gosh, shit. Just like what's right above the squared button, square root, they put inverses together. Yes.
Oh, you're yours.
I did. So here, you guys do this. What's natural log of 114.9? Everybody got that? 4.744, blah, 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 blah.
How many digits are we going to use? 3?
I would tell you. Normally I say 3 or 4, it depends on how I'm feeling that day. Which one of these is the exact answer? No.
LN.
This is the exact answer. This can never be exact. Never. Because I don't care how long you take to write it, you'll never get it all written down. Because what those dots mean, it goes forever. There's no pattern you can just put a bar over, and it never ends. It's irrational. So when I ask you for an exact answer, that's an answer that's only got logs and stuff in it, no decimals. And then I'll say, give me an approximate answer to 3 or 4 decimal places. That would be this thing. If I say 3 places, then that would be it. I like it. So you'd say approximately. I like it. People think that just because it has decimals in it, that means it's exact. And that's, of course, complete bullshit. Which one's the more practical one? Practical. Meaning, if I said, how many days will it take before I can go in there, there's not too much radiation, and you say, natural log of 114.9 days. The shit are you about? If you say a little more than 4.5 days, I'm like, oh, okay, I'll go in 6 days, just to be really sure. Right? So that's why we use this in real life, but this is the one that is exact. All right? Oh, I'm reading it off of there. What is 10 to the 0.199991? No idea what I did. I mean, if it's something interesting, but it's more than likely not. 3 9s in there. Four 9s in there. Shit. Didn't get enough coffee. Let's see if that's something more interesting now.
Not really.
Oh well. I can only do so much.
Yes, we turn numbers.
So 1.58. Where'd you go? 486. Blah 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 blah. Sweet. All right. Just to make sure, there's just 2 more buttons on your calculator. You know what this shit they mean now. So you will need the calculator a few places. I'll just ask you. Just make sure you can use your calculator correctly. I like it.
Which button do you use for the power again? Because I got 12.21.
So 10 to the is right above the log button.
Okay.
It's right above the log. So if you do second log. No. Yeah. Clear. Do second log. 10 to the. Cool. Hey, yeah, you could do 10 and then your little caret button too. That'll still work. Okay. Now, those are technical little details, nuts and bolts, should be super easy. Yes, I know I talked a lot about where the hell E comes from and all that stuff, but that just gives you an idea where the hell it comes from. All you got to be able to do is use them. Now, let me ask you this. Some of you guys might know this, but just how do you do log base 11 of 487 on your calculator? What buttons do you have on the face there? What log buttons?
Math.
What about math?
You have to go down to log base number A.
I like it. Let's pretend like we don't know that shit. All right. Because this has uses besides just this directly. You use this to kind of prove some other stuff. So there's something called a change of base formula. And it'll help us figure out what this is just using the log buttons on our face of the calculator. So let's figure out what this is real quick. So if I had log base B of x equals y. How do I rewrite that in exponential form? B to the y equals x. I like it. Now, what if I now said solve for y again? You could just go right back to where we were, but then we have the same problem. We have a base that I probably don't know, that I can't use on the face of my calculator, right? Let me stay with you. Where is the y in this equation? Up here. What's the only thing that we have that can bring that down? Because remember, if I have a variable on the bottom and I'm trying to solve for it, I've got to multiply it up. Because division's opposite is multiplication. It's amazing. What's the only kind of function I have that will bring a power down? How does the square root bring a power down? So if I have the square root of 2 to the 9th power, that 9 comes down somehow? No. Come on.
Oh, you do the log?
Yes. So if I do like ln of both sides, ln of this side and ln of this side. Why am I allowed to do that? Because as long as they do the same thing to both sides, and it's not multiplied by 0 or something, then it's legal. What can I do with the y now?
You can do the put it on the side.
I can just take it down, right? Y times ln of b equals ln of x. And then how do I solve for y? What do I want to get rid of? ln b. So I'm going to divide by ln b. So y equals ln x over ln b. All right, now, y is this, but y is also that, which means that equals this. Let me say this in words that'll make this stick in your head, hopefully. How do I rewrite some given log in terms of a log that I know, like ln? I take log of the inside divided by log of the base. Now they're all in terms of 10. Base goes on the bottom, base goes on the bottom. Gotta love that when that happens in math. Do you guys understand what I just said? It's a horrible feeling. Some of you guys are just like washing stuff over and just, I'll wait till he shows me a problem. But problems make more sense when you understand the ideas behind them. So in general, log base b of, let me just keep it the same way, x equals natural log of x over natural log of b. Or you could use log x over log b. Because I could have taken a log of both sides here, right? Log base 10. Why do you think math people normally use ln instead? Since both are the same. Why do you think we use ln instead? We're the crazy people that said let's not write a 2, so it'll save time. It's one less letter. That's honestly the truth. So you see ln used a lot more often. So I just naturally do ln's. You could do logs if you want to. Okay. But what's the difference between these two, ln and log? Ln is base e, and log, of course, is base 10. Common log, natural log. I like it.
Oh, so you do like anything as long as it's the same.
Exactly.
But it's just easier.
So let's see. Those of you with a calculator, help me out here. What is log 47 divided by log 11? I predicted it'll be like
2.5807.
Okay. 2.58, blah, blah, blah. Now do natural log of 47 divided by natural log of 11. Be really careful, too. If you're not speaking up and you're not getting the same numbers we are, if you have one of the older ones that opens a parenthesis for you, you got to close it. Or else it's going to put the entire thing inside that one log. Just in case you're not speaking up and you're getting totally different numbers, you're like, well, that's my life. Speak up instead. Yeah, there you go. It happens all the damn time. I'm like, on the test, they're like, I never get the right numbers. I'm like, why do you say this before the test? Shit. It's just how my life goes, Mr. Wall. Because you let it. You guys get the same number here? Oh, I love you. 2.58, blah, blah, blah?
Yeah.
Yes, okay. That is really kind of weird, but it's because we could have done any log of both sides of that equation at that step. We chose natural logs at first. We could have done log base 10. We could have done log base 11.872. I'm not sure why we would do that. That's why these two are the same. It's kind of neat. The ratios of different logs end up being the same number. It's neat. Okay. All right. Oh, I do have a handout somewhere. Yeah. There you go. All right, so do you see at the top, it's got the changing basis? Do those two real quick then. Number one, number two right there at the top, and then we'll get into 12.6, and then we'll take a break. It's about 57% showed up today. It's over half. I hate being happy about that. That's right. Doesn't matter. It just doesn't matter. What's really funny is both of these slight edge to using log, but it really doesn't matter if you're just going to take it down to an approximate answer anyway. Do you see how 0.1? What is 0.1 as a fraction? What place? 1/10. It's in the tens place, right? 1/10 is based on 10. To see how there's a 10 there, they both have things based on 10. So if you use ln, it doesn't matter. It's going to come out the same approximate answer. But if I use log, what does it look like no matter what? Log of 3 over log of... Yeah, it's going to be easier to remember that, hopefully, based on the bottom. Log 3 is whatever the shit it is, but log 0.1, what is the log of 1/10? What do I do to 10 to make it become 1/10? What do I do to 10 to make it become 1/10? Raise it to the... How do I make 10 flip and become 1/10? What power makes that happen? -1. So if you just do negative log 3, you'll get the answer. And then I'll do it again with natural logs. What do you guys get for this one? Anybody do this one?
Negative 0.47.
I don't really get how to do it. When I did it, I got -1. I didn't do
What'd you do?
the log, 0.1 parentheses to the third power.
Oh, that is so desperately not what this means. Help me out real quick. What's log base 2 of 8? How many 2's to multiply to become 8? 3. So it's not 2 to the 8th. Nowhere in there is there an idea of 2 to the 8th. Base 2 of 8. So the base is 2. What's the power? 3. The base is 0.1. What's the power to make it become 3? That's the question here. That is the question. Does that make sense? So again, the notation is weird, but that's the base.
I just don't know how to put it into the calculator.
That's what we're working on. You can't put this directly in the calculator using only the buttons on the face of the calculator. You can put this expression in.
So just divide it in.
That's the whole reason why we did this change of base formula, is so that I could use the buttons on the face of my calculator to do this. Yeah. You can't put this in directly because you don't have a way to put that in there directly. I like it. Now, if you did natural log, it would look like what? Natural log of
3.
3 over natural log 0.1. If you did that, you should have gotten the same thing. All right, maybe. But if I really wanted to, I could have stopped right here and said a better way to write this is negative log 3. But if all I need is an approximate answer, it doesn't matter which way you go, you're going to get the same blah, blah, blah.
How did you get -1 in the bottom?
Oh, all right. Log of 0.1 is log of 1/10. What do I do to 10 to make it become 1/10? What power do I put on 10 to make it become 1/10? 10 to the negative 1 is 1/10. Remember, log with no base, we understand it to mean it's got a base of 10.
Oh.
Yes, there it is. So just like a square root symbol with no number, we just know it's 2. You don't even think about it right now. You're like, of course it's 2. Why? Because you learned it. Log with no base. You haven't really learned it yet. You got to keep reminding yourself. That means there's a 10 there. That's all. Same way, square root with no number. It's a square root. If it's missing the 2, we know it's a square root. If it's missing a base, we know it's log base 10. Same idea. Really the exact same reason, because they're the most used ones. Move this over. So what about this guy? What was it, log base 4 of 10? Yeah. So if I use ln, that would look like ln of 10 over ln of 4. And that's something. Right. So this would be the exact answer. And here's an approximation. What do you guys get when you do that?
1.66.
Cool. I like it. 1.661, roughly, approximately. If you think about it, it makes sense. 4 squared is 16. 4 to the first power is 4. So somewhere in between 1 and 2 is the power that will make it 10.
I didn't get that. I got 1.975.
Neato. Oh, see how you didn't close the parenthesis?
Oh.
So you put that natural log of 4 inside this. So if your calculator opens a parenthesis, which is annoying as shit, it's like Microsoft Word saying, "Did you mean?" No, I know what I meant, Word. If you don't close it, it puts all of this in that natural log.
Okay.
Close it. Close it.
Gotcha.
All right. If you don't know what I mean about Word, then you haven't really used Word much. Did you mean? No. Thank you. Okay. And of course, if I use logs, I get the same idea. But this would be log what? 10. And what's log 10?
1.
What?
Pointer.
What?
1?
Are you saying 1?
Yes.
Okay. I thought you were... My first name is John. I thought you were just calling me in Spanish.
Oh.
C? K? I don't know. And then now, it's just 1 divided by log 4 does come out to be...
0.25.
You can check me. 1 divided by log 4 is going to come out to be the same thing. Yay! All right.
I have a question, Jeff.
Yeah.
It's kind of off topic, but how do you say when you want to go to the exam, and you want to clear out whatever settings were on the calculator, so get a double from there? Because certain settings would mess up the calculation of certain things.
Nothing that we've done should do that. If you're worried about memory storage stuff, that doesn't matter.
No, I'm saying like settings on, how they change whatever stat or app or whatever.
Oh! Come up and
Yeah.
show me when you hit a problem.
Okay.
Yeah. There's too many things I could try to tell you right now to do. I could just do them. Okay. Yeah.
So when did you know to simplify? Is it because it's a log 10? Is that why you changed it to 1?
Yeah, when the base matches the thing on the inside. So why is this easy? Because 27 is made of 3 3s. I mean, so 27 is based on the number that's in the base. So, then I could just get a nice answer. But what's log base 3 of 28.1129? I could say it's a little bit more than 3. But if I need the exact answer, I gotta get a calculator for that shit. Right? Maybe? No? So when I give you a problem like this, like log, what's log base 27 of 3 then?
Negative. 1 over 9? 1 over 3.
What root do you take of 27 and get 3?
3.
1 over 3.
See, that's, I'm really sorry, Jimmy, but you stated this, and now I must use an example. If I give you this problem on a test and you give me this answer, screw that answer.
Should be 1/3.
Sorry. It should be 1/3. It's a cube root, and that's what that's trying to be, but that will never be 1/3. Unless you put a bar over it. Even then, I want the answer to come from your brain, not from that. Cube root of 20. Now, do you notice something here and here where the answer is actually, 1/3? So what's log base 2 of 8 again? So what's log base 8 of 2? Holy shit. What's log base 4 of 64? 3. What's log base 64 of 4? 1/3. Doesn't that happen with 3, by the way?
I was on the test.
Yeah.
Yeah, I know. I'm the one who made it, by the way. Dan gave it. I made it. So in case you wanted to blame somebody, it's me.
Sorry, I just remembered that.
No, yeah. That was something you should have been able to do, Ben, but from what I've seen so far, no. But that's this interesting thing to notice. I mean, this is sort of because when I flip those, I should flip that to make it work. If it takes 3 of those to make this, then 1/3 of this is that. Goes back. It makes sense. Good. Okay.
Boy, made that connection on the test.
Gonna make this correction.
All right. So like I said, one more section and then we'll take a break. If you came in after I said this, obviously tests are not done yet. And
You're
12-7
gonna give out
made...
the homework before the end of class, right?
Yeah, for
For all the sections?
yes.
Okay.
Cool. Let me make a little list here. We're going to do 12, 5, 12, 6, and maybe 13 one. I'll fill that in before the end of the day.
Is all of, so you want to do all of 12.7 for extra credit, or was there a certain number?
Oh, all right. I'll give you a good point.
Thank you.
Okay. I'll give that to you later.